meeting 96 board session, which is probably really interesting and I wanted to go to as well, but we'll hopefully hear what happens afterwards about that. Just to set the tone for this, I'm hoping this is a pretty interactive session. I don't have many slides here. What I wanted to do was present a number of topics, the potential topics that we can talk about, and a few of those topics I can elaborate on with a few extra slides if needed, or get one at a grant or someone else to come along and talk about that particular topic in a little bit more detail. But if anything, any subject takes more than kind of 5 minutes or 10 minutes, what I'm hoping is we can just sort of get the interested parties' names down and go off and have a different discussion later in the week about it. So this is kind of a birds of the feathers session, you know, and try and identify who the right people are and go away and figure out the problems in more detail. So we're not trying to solve all the problems in this session. We're trying to sort of outline what they are in a lot of sense.
The big thing that we want to do is we want to come out with action items and what needs to be done. Specifically needs to be done this week, so that the people who need to sit down and talk actually do so. I'll be taking notes on the Etherpad, and any help on that would be appreciated. We normally have notes up in here. If someone would volunteer to put the Etherpad up on that I would do it, but I don't have my dongles. So.
And I'm presenting. So.
You're presenting. So the Etherpad link is on the schedule page.
Okay. Still people coming in.
What's that?
If the cable reaches,
I will borrow it if it reaches and all.
Oh, actually, I say that. I like it.
You've got one? No, this is the PGA.
Okay, I think I'm just going to have to repeat what I said a little bit because about half the room's just entered rather than.
Give it till 5 minutes.
Okay. I think we should get going anyway. I'm just going to quickly repeat what I just said. So this pretty informal session. The idea is we're going to go through a number of topics and just present at a very high level what it's about and what we think the issues are, and then if there's further discussion needs to be had, then we should go off, identify the relevant people and have discussions later in the week. So we're not trying to solve all the problems in this session, just try and set the tone. Okay, so I'll just present this, a few bullet points to try and scope the discussion, but try the other side. It's only on one side, I'm afraid. Yeah, so I'll just present a few bullet points, and then hopefully people will pipe up if they're interested. If they're not, we'll just move on to the next thing. Okay. So firstly, I just wanted to advertise. Charles has got a session tomorrow. Charles Gossier-Tobin, our AT security architect, so talking about the PI and SMM, or just MM in the new parlance, so management mode in the PI specification within the UEFI forum. So this is a UEFI members meeting only. Hopefully the relevant people already know about it, but if you don't, then I think it's 9:30 tomorrow.
Yeah.
So go to that. I don't know if there's anything more you want to say, Charles, and what the subject is.
So it's in, we're taking over the TSC room, so Sand Pebble, E and D.
Yeah, over on the other side.
Yeah, and we're having a session from 9:30 to 12. We've actually been running meetings on this topic for a while because there was an interest by OEMs, this is enterprise really, OEMs, BIOS vendors and semiconductor vendors, and having some way of collaborating with firmware. And although SMM's an Intel thing, now it's called MM, and we see a lot of movement in the ARM space. So the only other thing I'd say is that if you want to be in that discussion, to let me know. So try and want to make it as inclusive of the ARMv system as possible. We've advertised it a few times, and there's quite a few companies there. If you want to be in there, just let me know.
Okay, thanks.
Oh, sorry.
You don't have to repeat it, but use mics.
We'll pass around the mics. I don't know, are these being amplified? Or am I just speaking louder? Okay. Okay, so next topic, a few people have asked me, so is there a trusted firmware session this week? And well, there isn't really, but this is probably the only chance there is. So if it's not too indulgent, I was just going to present 2 slides on trusted firmware and where that's going. If we want to discuss it further in terms of requirements and what we need to do, I'm happy to discuss later in the week in a sort of smaller group. I might just go straight into that now, if that's okay, rather than go through all the... Is that all right? Yeah. I'm just going to switch presentations. Just 2 slides quickly. So the summary slide is, we're trying to provide some reference boot flows on 64-bit ARMv8-A systems. So the diagram there shows a relatively complex boot flow on our Juno development platform, but the key takeaway is that you don't have to use all of those pieces, and not all of those pieces are relevant for all platforms. So quite often when people say, oh yeah, we support trusted firmware, we just mean this kind of secure monitor part, this runtime part, otherwise known as BL3.1. So this BL3.1 is compatible with it, other types of boot firmware, or can be used in standalone in some systems that have some other processor for helping do the firmware loading part. So this is really, it's the runtime firmware aspect, which is the part we've been focusing on most. It's agnostic to the normal bootloader, whether it's UEFI or U-boot or whatever else. And another misconception is that it means you've got to have a trusted OS with it, and that's not true. You can have a trusted OS, but it's still applicable on segments that don't have a trusted OS. For example, the PSCI implementation for CPU power management. So yeah, it's been very successful in terms of the runtime firmware aspects. We're starting to look at some of the boot firmware features now in the so-called BL1 and BL2, where the secure boot or authenticated boot it becomes important. So I'm interested to know if there's any feedback on features there and where we should be going next, because the balance is always knowing from an ARM point of view where to place the investment next. So just in terms of features, so just broadly split this out into so PSCI has been the major piece of work in trusted firmware development. There's a v1.0 specification of PSCI which added a number of optional features over the previous version 0.2, and we've been working through those optional features. Recently there's been quite a major patch set provided to improve the flexibility on the topology definition. Before there was a lot of assumptions around the NP-IDR structure and how the power domains are, but now that's kind of been abstracted away, and there's support for the so-called enhanced power domain format stuff, and that's all in there. Charles is smiling.
No, it's
Okay.
a few people involved in that effort on the spec section.
So that did involve some breakages to the platform porting interfaces, but we added a compatibility layer for that at the same time to try and ease the migration path. So interested if any people's experiences there, if that's worked for everybody and whether they're finding it useful. There's still some more optional features but some of them are going to cost a lot in investment. Things like the OS coordinated mode, and we'd probably only implement that if there was a strong feedback that was what people wanted, and it's demonstrably a better thing than the existing platform coordinated mode. I'm going to move. I'm talking too much, I think. So trusted board boot. We've added more interfaces around improving abstractions to the underlying crypto libraries, and soon we'll have added all the mandatory features there. We're interested to know whether people want us to add more of the optional stuff and whether they're actually going to use this stuff. So we're not actually sure people are actually using this in real systems yet, this early authenticated boot code. Sorry? Yeah, okay. Oh, sorry, what company? Broadcom. Okay, that's good to know, thanks. Okay, maybe we can talk about later about what features you think need to go in there. In terms of system IP, there's an outstanding pull request for a CCN driver, cache coherent network. So, and as part of that, we've made the code safe in the presence of system caches. So that basically involves doing things like flushing caches by MVA instead of setway. So we're probably going to merge that tomorrow, unless anyone's got any problems. Git v3 support, I've got more to say about Git v3 if people want to talk about it, but I don't know if that's on people's radar yet, but it has some big implications for Trusted World, and especially Trusted OS. We added some stuff around firmware interoperability using with other boot firmware, and there's a couple of platform ports upstream now as well from NVIDIA and MediaTek. So that was all I was going to say on Trusted Firmware, unless. But if people want to know more, sorry, yeah?
So do we have any roadmaps for firmware?
Yeah, we have roadmaps, but sorry, the question was, do we have any roadmaps for Trusted Firmware? ARM tends not to present roadmaps in public forums, so we'll have to have a sort of more one-on-one meetings if you want to see roadmaps. So come talk to me afterward about that. Okay, so switching back, the other topic was Git v3 impact on secure world architecture. I'm a bit reluctant to go into immediate detail on that now. I'd rather come back to that if we've got time, because I'm afraid my slides might take too long to present there. But basically, there's it adds support for an additional interrupt group, which adds potentially additional use cases around handling interrupts at EL3 as well as secure EL1. So, is this something people are interested in? Maybe we could come back to later. Yeah. Okay, I'll come back to that one once we've. There's another one around ARMv8-A support. So trusted firmware really only is targeted for 64-bit systems. We don't think it's worthwhile investment to try and get the same code running on 32-bit systems as a whole, because that implies too much churn and impact on existing trusted OS and other secure world code. So, but what could be potentially useful is providing additional library support, like the PSCI library aspects, or maybe some other IP support like Git v3 in a 32-bit system. So I'm interested to know if anybody's got any requirements around that, or interest and demand, and maybe we could start a new project, or even make this part of trusted firmware if there's demand there. Is there any feedback there? Does anyone care about? Is everyone happy in the 32-bit world, or is there any demand for sort of more generalized IP library support?
Actually, I'd like to hear about the Git v3 impact on secure world architecture.
Yeah.
What exactly do you have in mind?
Yeah. I did want to, as I say, I've got a few slides on that. I'm just conscious of hijacking this session for the stuff I want to talk about, which might not be what everyone else wants to talk about. That's why I wanted to go through all the items first and then come back to that.
I think it is worthwhile go through the whole agenda and highlight the things that we're going to go back to. So Git v3, spend some good time on that one once we get through this list, and then there's a couple other things I think will come out as well.
Yeah. Okay. Next one. I don't know if Ardo is here, but I think Grant. Oh, sorry. Yeah. Maybe talk about this idea of having a common support for boot path architecture. We're starting to add authenticated boot into trusted firmware. There's also UEFI secure boot, and then there's higher levels of the system also have their own stuff. And can we share some software here? So maybe you've got some thoughts here.
Do you want to talk, or do you want me to talk?
You can start.
I will start. Okay. So the idea, what we've been tossing around, I've got a white paper on this topic as well, is what does the security look like from an overall system perspective? So we've got a lot of components. We've got our Untrusted firmware. we've got opt-T or some other T, we've got the normal world. We've got, depending on the market, vendors want to use, some want to use UEFI, some want to use U-boot, some want to use something fastboot derived. All of those silos right now are doing all of their own engineering for security top to bottom on what it should look like. And when we were looking at this, there's getting keys right, getting the infrastructure right for managing certificates and keys and managing secure updates to firmware data is hard. So the question is there, can we put into place, can we define some common architecture for how we do the interface between the normal world and secure world? Can we define some common interface for how we provide services through calls that are probably very much like standardized, very much like PSCI has been standardized, so that regardless of what the firmware implementation is, we still have the same set of interfaces that look largely the same, regardless of what the overall, regardless of what the system is and what decisions have been made for the normal world firmware. So that's where the thought came from, or that's what we've been talking about. And I wrote a white paper on that's discussed some of the issues in some of the different areas. Android, of course, is the big one. Enterprise UEFI, embedded with U-boot. Art has been exploring and investigating on what an API could look like, and has been doing some prototyping. And I think we're starting to come together on what an API would look like. We think that the right approach is to try to define APIs. Upstream support for this API into Untrusted firmware and opt-T, but not try to standardize on specific components, so that we've got an architecture defined, but not try to go to the point of saying you will use this piece of software to implement that architecture. So, do you want to elaborate a bit?
Add a bit to that. So what I looked into and what I prototyped some bits and pieces of is, starting from Ron's white paper with descriptions of how on U-boot and UEFI boot image authentication is implemented, and also taking into account what the Android world does. Try to kind of abstract from that and model that as an abstract key value pair storage service that sits on the secure world boundary. So, for instance, I don't know if Linus is here, but one thing he suggested was self-revocation. So, a secure, a monotonic counter basically, which could easily be modeled as a key value pair with something in the background in the secure world that implements the policy of this particular key value pair being a monotonic counter. The same you could do for UEFI, where there's lots and lots of variables with all different semantics and different kind of state change requirements. But basically, same would apply. You could split it into a kind of abstract key value pair interface with something that backs it, which implements the actual policy. And that would allow us to standardize on the interface, but still have lots of flexibility in what you don't want to implement if you're not interested in UEFI. So yeah, I'm just prototyping UEMU, working on some hypervisor calls and trying to see the whole sequence happen. But it's mostly paper exercise and some discussion about proposals.
So I'm definitely interested in talking to you more about this week, and so maybe we'll arrange that. Are you interested in that as well, Jason?
Yeah.
Okay, you got anything to say now?
I'd like to see what you've done. Sounds great.
Okay, so where we're at with this, it is early stages. We've got kind of a prototype API we've got a draft API. We've circulated around a few people within Linaro, and was going to have a little bit wider meeting, but Connect approached much faster than we expected it to. So now we're at Connect. Now is the time to sit down, and I think I don't know how well it would work in a group this large. I would like to kind of talk with a few experts around a table with lots of paper to hand, and maybe if we can do that earlier in the week, we might be able to find time to do a larger session later in the week. So if we do that, I'd like to have a list of names of who's interested in being involved in that, and I'll take the action to set up a meeting.
Maybe the best thing to do is, like, at the end of this session, just people come down who want to be involved in these discussions, and we'll take names and do that all in one at the end. Okay. Move on to the next one, I guess. Kind of in a related area, just secure firmware interfaces. Is there anything else we should be doing? This could be in terms of the interface between the cold boot interface between the secure world and the normal world, or it could just be more standard SMCs. This cropped up originally because we were adding some platform-specific functionality on the Juno platform to be able to tell the normal world bootloader what secure DRAM regions are being reserved by the secure firmware. So this enabled us to make modifications for certain use cases, like some media use cases which wanted additional carve-outs of RAM, but you didn't want to rebuild UEFI for this. So that kind of provided an abstraction there. But people said, well, hang on, if you're doing this for Juno, why don't we do this for, make it more generic? Or so I was just wondering if there's any appetite for something more generic here, or is there other kinds of stuff we should be passing to the normal world bootloader here that people are interested in? It's probably quite hard to standardize. It's probably useful stuff to pass over, but it's in my mind, things like, board information or the power controller facilities, but it's pretty hard to imagine in my mind, apart from the secure region stuff, around generic
Why is
stuff.
that not in firmware tables of some flavour? And if it's not in there, why don't we add it?
Firmware tables that can be read by the trusted firmware and acted on.
Well, that's an interesting one. That's basically we could talk about trusted firmware or whatever firmware, secure firmware, reading device tree information.
In the kind of discussion,
Are you reading it or generating it?
what's being discussed, actually providing descriptions of memory areas that people can access or not access in tables in that way.
I think it makes sense. I mean, whatever gets implemented on Untrusted firmware, I'm not even certain that we need to go through the process of standardizing what this thing is, because what Untrusted firmware implements will be the de facto. If it's to define a structure, in one sense, it almost doesn't matter what it is, as long as it's extensible and defined. So, whether it be a device tree or flat tables that are identifiable, we can add new blobs of data as we need to. So, memory regions are really easy.
Yeah, sure.
Devices become harder. If we need to start attaching flags and that to specific devices, in which case we need to make sure we have a sane way to describe it.
The other classic thing is the CPU topology. Yeah, I should use mine. Sorry, the other classic thing is the CPU topology that you want to be able to share between.
Yes. So but I think all that makes sense. I kind of feel like we need a draft proposal. We can talk about the sorts of things that we want to do, but we need to have something concrete.
We certainly have some draft code for the secure region interface already, but for anything else we don't yet. So I was kind of more gauging interest really at the moment, and then if there is interest, I think we'll try and propose something. Is anyone finding this a problem?
So this kind of seems like it's drifting into an area that I care about, which is venue, where when QEMU can emulate secure mode, we would like to be able to provide a device tree to the secure firmware to say, this is what the hardware you're running on looks like. So that the secure firmware can then say, okay, that's my device, that's my device, that's my device. I'll now edit the device tree or whatever, pass the non-secure guest a device tree that looks like what the non-secure guest can see, and so on. But in order to do that, you need to be able to have a device tree where you can say, this device is only secure, this device is only non-secure, this device is visible in both, or that kind of thing. So one of the things I kind of like to do this week is to find the right people. And we've had a discussion at Last Connect, and it would be nice to actually see if we can nail that down into a definite, this is what we want it to look like in device tree.
Well, that sounds good. So that sounds like another one we need to
So
schedule.
We do need a project. What's the action on this one? Because I don't think we're going to, we're not going to have time to talk about it in this session.
No.
Do we want to, is it worthwhile booking a meeting this Connect, or is this a?
I think we should try and have meetings connect, yeah.
Do you want to take that action?
That might require me going out to meetings.
I think that was a yes. Peter's going to.
Peter/Grant. There we go.
Grant to train Peter on Pathable.
Yeah.
Okay. Page 2 on the possible things. That gets a bit more woolly as we go further through this list. So I don't know if there's any segment-specific stuff people are interested in. I don't know if possibly encroaching on Charles's thing tomorrow is other use cases in enterprise systems for a trusted OS, or is it just very focused on providing some framework for other
That is framework, and actually, the APIs there will be defined. Sorry, that is framework. Is that on? Does it sound any louder? No, that's not.
the numbers on at the bottom?
Just talk loudly, and I'll play with
Okay.
this.
That's right. So that stuff is all framework, and it's all defined would all end up being defined within the PI specification of the UEFI set specifications. And actually, but it's defined just as APIs. So actually, if you wanted to implement those APIs with a trusted OS, for example, that's possible, which is kind of a nice potential in for a trusted OS into enterprise. But if you wanted to implement them by creating your own security on one payload, for example, you could also do that. So the point of that discussion there is to keep it at an API level.
Yeah, I'm going to hijack this topic a little bit as well. One of the things that I'm nervous about, architecture-wise, is we've had a lot of ideas being thrown around on how the trust zone is going to be used, how the secure OS is going to be used. I don't think we've got a good idea on how secure application or trusted applications are going to be segmented and protected from each other in a real system. One of the examples that we came across when we were looking at the trusted variables is there's variables in there which cannot be, if we're using the T as like a TPM, then there's secrets in there that can't be accessible anywhere else. Do we have the sufficient technology or the sufficient trust of the system for opt-T to implement TPM functionality and keep that data away from any other trusted application? So I'm hijacking the discussion. I'm not sure where to go with it. I'm not sure if how to talk about it.
We have that kind of support already. I mean, the trust applications are sandboxed today in opt-T.
Yeah.
So.
Usually it's an MU at the end of the use and separate
Yeah.
all that, don't you? So as long as you trust opt-T, you're fine.
As long as you trust opt-T, you're fine.
Yeah, that's your trust boundary.
Yes.
Does raise a good point whether there are additional sort of trust boundaries that we need to think about. Maybe some keys, there's kind of an assumption that the trusted world can see everything, or at least secure EL1 and EL3. Are there actually some bits, even some parts of the code that's running in there shouldn't see everything? There's some keys that only should be temporarily accessible to certain systems and things like that.
So, and it's in the model where we've got pluggable things that can go into trust execution, when we've got things like there's a large surface area of attack.
Agree.
And I don't think we've got a good answer for it yet.
Yet. But that's one of the reasons to trust the OS is one we've implemented. Still. Yeah.
So I don't know if we came out with anything there to sort of generate further discussion this week on, or I think people have got opinions, but it doesn't sound like there's any, concrete proposals that we can.
I think it's a topic that needs to be discussed in your session. And Leif will be there, and he's opinionated, which is a good thing. I think the stuff that Ard's been looking at, we're going to start picking at the corners of it. So I don't think we're quite ready to talk about, like, I don't think there's anything to do at this Connect, but it's going to be coming up in the next couple of months as we're actually working on code.
Agree with that, yeah. Okay then, maybe this is something you can help with. Any missing services, drivers and features we need to be thinking about, especially up to you?
I would happily receive requirements. Or, I mean, if you have ideas, requirements or whatever when it comes to Opti, please talk to me because I'm very interested in knowing more about it.
Is there a session where you're going to be talking about Opti?
Right after this session, we have a core dev lighting talk, so I will wrap up what we have done the last couple of 6 months and what we're doing right now in the near future. But there is also some public meetings, so talk to me if you want to be included in that public meeting also, because I don't think you find it impassable. And then we have one session about the kernel driver and about secure storage this week, so in Opti.
Thanks. Anyone else got any specific features they're looking for? No? Okay, just another subject I just wanted to touch on was what we call security hardening, but it's got many different names. It's something we're thinking about in more Untrusted firmware. People start to ask us difficult questions about how much we've certified the code and what have you done to prove that it's trusted. Why is it called trusted firmware if it's not trusted? So we're kind of doing a little bit more around this. So we want to get some of the basics in place around threat modeling and processes for handling security incidents and things like that. But eventually we want to get to a stage where maybe we could do some code auditing or third-party code auditing and penetration testing and things like that. But it probably only really makes sense on if this is done as a kind of in an ecosystem sense, rather than just sort of say you can't really do penetration testing on a generic frameworks. It's got to be on real systems, and it'd be good to kind of share findings here if everybody's doing the same kind of auditing on the same individual devices.
Have anyone who do attacks? Try attack software. I think I said that loudly.
What you want to do is you want to offer prizes.
Yeah, that
Very simple
yeah.
bounties, and put it in two things will happen. Put bounties out there for define exploits. Number two, get some very popular consumer device that's locked down, it's not got a root logo on it, and suddenly they're going to find all the exploits for you, so you just need to incentivize them to report them by having a bounty in the plan.
But do it reasonably privately in Linaro, so this is not all made hugely public.
Yeah, just to summarise what John said, if you didn't hear him, the suggestion was to have bounties out there so people can sort of go away and feel incentivised for breaking into these systems. I think that's really useful if you've got a kind of baseline confidence in your own system. You've actually done some testing yourself, and you don't get embarrassed with really stupid breaks that you shouldn't be.
No, I think it's only part of what we can do for security. We need to have that pen testing. We need to have some experts who think in that way. I mean, so many of us engineers are optimists, and in security you can't be. So that's something.
So as I say, I'm thinking about stuff here.
We should talk about afterwards if that's something that we can do in the security working group and what that would look like, whether or not we can get an engineer staffed on it.
There are companies for hire that would do that kind of work also.
There are companies from hire, yeah.
That dovetails with nonce replay attacks and upgrades. Nowhere here yet have you discussed preventing downgrades and how you handle the upgrades.
Part of the trusted board boot requirements specification that ARM produces and trusted firmware is supposed to be implementing is having support for non-volatile counters and preventing downgrades.
Yeah. And we talked about exactly the same thing on common architecture for secure storage.
But it probably comes back to this common
Yep.
verification
Yep.
stuff.
In terms of hardening, are you looking at any governmental certification?
Governmental certification? No, not yet.
Because there's NATO standards, there's US standards, Canadian standards, and they're very difficult to get through.
Yeah, absolutely. I mean, we totally know that some of these bodies are, there's many different profiles and levels, and you can spend as much money you want on this, and it's really about providing some sort of targeted, sort of general purpose starter frameworks and auditing, and then people will have to build on top of that for whatever applications they're building.
So you actually have to have a product to do PAL or fix or something like that.
Yeah, so I was going to say, is that really the point? I mean, if you're an open source reference implementation, what's the point of having it certified? I mean, everybody can use the code, everybody can put it into their product, and this certification is not going to carry over to the final product anyway.
So this has come up in discussions about safety critical systems as well. I think there's some value in doing the legwork ahead of time on prepping these projects for certification without actually doing the certification. So this would be looking at what the requirements are, making sure that we've got tools in place to test against the requirements, so that when a product goes to market, they've got they've already got a jump start to getting towards certification. So I think there's some value in that. We've had some discussions about it, or I've had some discussions about it with various companies. A project hasn't come out of it or anything like that yet.
But are you going to discuss it more, this Connect? Or?
There wasn't plans to discuss it at this Connect. This was actually related to safety critical systems, and we don't have a group or anything that's formed out of that. So
okay.
It's something that it's an idea that's been raised several times.
Yeah. Okay, so I guess what we say, if anyone wants to know more about ARM's plans in this area, come and talk to me in private, but for Linaro's plans, we'll come back to this, I guess.
Was all this focused around V8, or is anything?
I'm mostly talking about V8-A, certainly in the context of trusted firmware. On the previous slide, there was a bullet point about should we be doing more in terms of library support on 32-bit systems. We think it's going to be hard to sort of introduce a new frameworks like trusted firmware into the 32-bit space because of the impact on existing trusted OS. But, sorry?
It's a little too late.
Yeah, exactly, yeah, the horse has bolted already. Yeah, okay. The last thing on my list is just around non-functional stuff. So I'm also worried about performance and more RAM budgets at the moment, especially if we start to have many core systems and you want a little bit of secure world code running on every core or on many core systems. Have you got enough on-chip RAM? Do we need to start thinking more innovatively around only running on some of the secure world, only running the secure world on some of the cores, or just really optimizing the amount of code that runs on each core? The other one is around performance and especially tracing. Use cases go through many components here, through trusted firmware into the normal world bootloader and Linux and maybe user space software. Should we be thinking about what those use cases are and defining common trace formats and non-invasive ways of capturing data about those use cases. Does anyone been thinking about that or care about that?
So on the tracing things, they were talking about latency tracking type APIs as well.
Yes, I know in ARM we've been thinking about it. I was just wondering if anyone outside of ARM has been thinking about it, or whether we just carry on talking amongst ourselves within ARM.
Well, it's just slightly different to what you've expressed as well, right, Nick? So we've been adding, the idea is being to add APIs so we can measure how long you spend in PSCI or how long you spend in whatever's beyond PSCI, etc., in a way where you can define your own timestamps effectively and use that to track the quality of your implementations. And I guess the question is whether that is something that is interesting to others. Then I'll jump in at once.
Yeah. I didn't get any huge mention there, so we'll probably skip that one unless people come afterwards.
Yeah.
So I'm going to try and open it out if anyone has got anything else you want to say. Otherwise, I'll
So
come back to
you would
Gig
want to talk
V3.
about Gig V3,
I'll come
and
back
we
to
have
how
10
long?
minutes left.
Okay, that's not bad.
So if now would be a good time to jump into the Gig V3.
Okay, I'll do that if no one else has got anything else. Not that one. Okay, it's a bit hard to know how to pitch this because I talked to some people, Gig V3s, yeah, we did that ages ago, and for some people, I've never, what is it? So I'll try and sort of pitch it somewhere in between. Just broadly speaking, I think this, some of the words here were on one of the Linaro engineering updates slides, so hopefully most people are aware of Gig V3 at least. It's basically, it's laying a foundation for scaling up systems for more than 8 core systems, and it adds support for these message-based interrupts, so you can have very complicated mesh-type topologies and scale up. In terms of this discussion, I'm more interested in around this enhanced security model and what that provides and what the impact is here. So there's other features of Gig V3 that we can sort of save for the hypervisor guys to talk about, things like the message-based interrupts and the translation service and things like that. I don't really want to go into. But it also has this support for legacy operation in Gig V2, but eventually that's going to disappear, and that's partly what I want to talk about as well, is how do we do that migration from a Gig V2 architecture to a Gig V3. Okay, moving on. So in terms of the security model, the main difference is this new interrupt group. For Gig V2, you have kind of group 0 and group 1 interrupts, and group 0 is kind of use FIQs for group 0 and IRQs for group 1. Moved on. So there's still only FIQ. There's still only the 2 interrupt lines, FIQ and IRQ, but they're kind of used a bit more innovatively in the Gig V3 space. So the idea is that you have a secure group 1 and a non-secure group 1. You still have to manage that within the 2 interrupt lines, but what it allows you to have is basically interrupts targeting to EL3 as well as to secure EL1, whereas before you probably had to choose one or the other, or have some special magic interface between the 2 to handle that case. So in this case, basically FIQ just always means go to the other world. So I think some of the architects probably envisaged a canonical model in which basically all other world interrupts go to EL3, and then you do a kind of context save and restore and it goes to the other world. But in reality, that's not how systems look. Most trusted OS always track the secure interrupts to secure EL1, but also some of them track the non-secure interrupts to secure EL1, and in order to do some stuff, whether it's saving task state or offloading to another core, before then passing control to the normal world via some SMC interface. And that's what Opti does and some other trusted OS. There are other trusted OS, though, that do basically the trusted OS doesn't track the non-secure interrupts, and it goes to the normal world first, and the secure world doesn't get involved at all. That's a so-called symmetric model. In trusted firmware, there's this test secure payload which supports both of these models for, to demonstrate that they both can work. So GigV3 enables, it's useful to have this support for dedicated EL3 interrupts for maybe sort of future use cases like RAS or some other handling that you want to do at EL3 but not affect secure EL1. And it's useful because it means you don't have to shoehorn stuff into GigV2. So one example is if you've got, say, an ARMv8-A secure OS and an ARMv8-A EL3, but then you want to do something with the secure generic timer, the secure OS can't see it, but so you need something at the EL3 level in order to get access to that timer, but then you want most interrupts to still go to the secure OS, so you have to kind of start inventing interfaces for the management of that, and GigV3 will help with that because you can potentially have interrupts going straight to EL3. So we expect the general sort of interrupt handling structure to be the same in GigV3 as GigV2, because we don't think trusted OS, even though you could move to this canonical model in theory in GigV3, I don't think that's really going to happen. People aren't going to, trusted OS vendors, maybe you can comment, Joachim, you don't really want to sort of move to a new framework probably just to get exactly the same functionality. That's our anticipation. Okay, so just a quick bit about how we're handling this on trusted firmware and the implications for other systems. So broadly speaking, this diagram shows sort of hardware systems and software systems. The different, broadly speaking, GigV2 only hardware systems, GigV3 only hardware systems, and then systems like Gig500 that support the legacy mode. Similarly, on the software side, there's a number of different potential software configurations. You have the architecture provides a lot of configurability here, but broadly speaking, you'd probably have an entirely GigV2 stack in the secure world and normal world, an entirely GigV3 stack in the secure world and normal world, or a GigV2 in the secure world and GigV3 in the normal world. And that's currently what we do so far in trusted firmware. If we're trying to support GigV3 systems, we run in this so-called S2 architecture, this middle space. But we've found some problems with it, which, so I'll just mention, we have a current driver which kind of operates in that space, but the middle box causes us some problems. It has to do a lot of additional work, and there's kind of has to make us try and understand what the normal world's doing, which may not, those assumptions might not always be true. And we think it's probably a bit buggy as well. But rather than solve the problem in a generic sense, because we think it's, one, really hard, and two, people probably won't use this driver because we know people who have GigV2 only systems, they don't want all this additional crud for GigV3 management when they have a GigV2 only system. So they're replacing this driver support in ARM trusted firmware with their own GigV2 only driver, and so that made us go, hang on, if this is not being used, then maybe we're doing the wrong thing here. So our plan is to actually move to a system where we have two different drivers, a GigV2 only driver and a GigV3 only driver, and the GigV2 driver can still operate on systems where you've got the GigV3 with GigV2 legacy support. There's a little bit of additional code you have around the power management paths, but it's not too onerous, and we can probably add static configurability to compile it out. And similarly, in the GigV3 space, we think we can handle both those two cases without too much difficulty. But the implication is that effectively we deprecate that middle option, and the implication is that it kind of forces people to move to either doing a GigV3 complete system or a GigV2 complete system, which we think is okay, but I want to test that.
So, make sure I understand what you're saying. In the
in the symmetric cases, you've got secure world, so secure EL1 and the normal world. They both have to be running gig v2, running the gig in v2 mode, or they both need to be running the gig in v3 mode.
Yeah.
And if we have a system and firmware provides gig v2 support, but not gig v3, the kernel can never use v3 mode.
Correct. So, yeah,
so
but you need to choose, in your compiling your secure firmware or your secure world code, you need to choose whether you're A, using gig v2 or B, using gig v3, or actually we're looking at the option of compiling both drivers in it and being able to select that at runtime, but that's a little bit more work. We don't know if there's demand for that.
Okay, so when I look at this, I immediately see support problems, like just in terms of what's compatible with what. And it may be fine. It may be fine to say, you know what, there's too much complexity here, that the system supports what the system supports, and the kernel just has to live with whatever firmware has chosen. That might be the answer to it, but it immediately, that's immediately what I see, is that if someone buys a piece of hardware, buys an ARM machine that for some reason they want to run a kernel that uses gig v2 support, that's not an option. And I think we're probably at a place where we've got all the support in the kernel. We're probably not going to run into any software support issues, but the potential is there.
So there is only a gig v3 as a valid hardware option to build. So as a kernel, you have to support that. You can't say we're not going to care about it. And it sounds to me like if the firmware says I only support gig v2, or the firmware says I only support gig v3, that's exactly the same as if the hardware had made the choice.
And also, if you've got that legacy software that only does gig v2, there are virtual machines and we can emulate.
Yeah.
Okay, that's right.
Okay.
In servers, the VM situation is the only case that really falls out, because the SBSA basically says building an 8-core system is gig v2, it's more than 8 core, you must use gig v3. So we already covered the server base, the only one we didn't cover. We did discuss it at the time, was the VM actually for gig v2, 8-core or less VMs, but like you say, you can emulate that. So
also, if you're targeting SBSA, then your software targeting SBSA, you've got to handle the gig v3 case.
you did. But you might have
Well, you could put up the straw man that what if firmware decided only to do gig v2? But I think that's a very big straw man, because you're shipping a product and you can only use 8 of the 24 cores you provide. No one's going to ship that product. So, yeah.
I think that's the message. I think really the issue here is probably not so much in enterprise, it's probably more in mobile, and it's probably more a message not to Linux folk but to trusted OS vendors that actually, if they want to support, if they don't want to screw the system into not being able to do free support going forwards.
Yeah.
So they have to figure out what the upgrade plan is.
Right.
I think
Makes
that's what
sense.
the message is.
Yeah,
That
I
makes
just wanted
sense.
to add a thing about when people were talking about emulation and VMs, is that you need the hardware support to do a gig v2 inside a VM as well. So if the hardware is gig v3 only, your VMs must be gig v3 only, even if you've only configured them with 2 cores.
Yeah, no, there's a number of debates that are going to happen as
Well,
people realise that piece.
that is the way the hardware does things, and there is no easy way of you wouldn't want to emulate the gig anyway. You want to use the hardware's acceleration support. So, but I think again, it's that your guest kernel will be able to say, "Oh, I look at the device tree, or I look at the ACPI, and it will tell me what kind of gig I've got, and it can just cope." So I don't think it's going to be a problem in practice.
Okay, fair enough.
So just to follow on what Charles was saying, it's just providing the support, and I think Trusted Firmware will provide the support, and it's a problem for Trusted OS, but hopefully it'll be a small problem in that we'll provide a new driver, and if there are any API breaks, we'll try to provide some compatibility or a migration path, but hopefully it should be fairly trivial for you to move to that.
Okay, so I'm going to break in here. We are 5 minutes to the hour.
That was it, all I had.
Thanks, Suzanne. Okay, so we've got 2 action items. Discussion about, we've got discussion on the secure firmware boot variables and interfaces. And what was the other one?
Yeah, that's right. Maybe,
the
maybe
firmware
device
data.
tree or other kind of
Right.
firmware interface for managing secure regions.
Okay, so anyone who wants to be involved with those discussions, come and see me or put your name into the Etherpad, and we'll get try to get that set up in the next. Find a time sometime tomorrow.
Yeah.
So, okay, thank you, folks.
So,